Okay, so what do we want to say, 30 feet again? Okay, so if this is 30 feet, that's another 60, so let's say 85. So let's say this is 85 feet. This is 30, 30, let's say 70. Let's say this is 70 feet. Let's say that the height here is 21 feet. And let's say the height here is 17 feet. So this is point, let's say this is point A, point B, point C, point D, point E. This is great, it's giving you more practice on double area method, right? So we have A, B, C, D, E, and back to A.
Can we get a height on E, or are we saying it's the same height as D?
Ah, good point. Yeah, let's say it's 17. Does it look, when you see it, does it look lower? Yeah, it looks lower to me. Let's say 15 feet. No, let's say 16, just because we're already using a 15. I don't want anybody to get mixed up.
Why you said that the height of B is gonna be 0? Isn't it 21?
So remember that, where's the origin? The origin is always the center of the roadbed. So everything is being measured from here,
Right.
right? So if this is the origin, on the Y value, B and C are gonna have 0 on the Y, right? E, though, is gonna be below, so it's gonna be a negative 16. And how about A, the 21 is gonna be negative 21, and the 17 is gonna be negative. And anything else should be negative? B's X, A's X is negative. So can I just stop you for a minute before you go on? Okay, first thing, everybody stop. Look up here. First thing we do is we figure out where's the road gonna be. Everybody's cool with that. You know, this is the road. This is the road, this is the existing ground surface, and these are the points that you surveyed. Right? Then you know the center of the road is the origin. Everything is getting measured off of this. So if this is an XY, if here's my X and here's my Y, you know that these three are going to have a negative Y value. And you know these two are going to have what? A negative X value. And A, E, and D are all going to be measured down from the origin. So first thing, where's the road bed? Is it cut or fill? It's fill because it's above. This is the existing ground surface. Always put your origin at the center of the road and then figure it out. Anybody get a number yet? What'd you get for the double area? 3,050. Did somebody else get a number? Did you get the same number? Kalika? So then this is 1,525 feet squared.
Oh, we don't understand that.
No, because this is just area,
Oh.
right? It's just area, it's the area. Oh, I didn't mention over here that everybody okay with that question? I wrote the equation up here, but you need to know it's called the end area method. Makes sense. You're using the end areas. But there's another method. There's a prismoidal. Which is the volume is equal to area 1 plus area 4 times area 2? Is it 4 times?
Probably was 6, wasn't it? And then divided by 6.
Let's see, I'm pretty sure it's times 4. What you're doing is you're weighting, W-E-I-G-H. You're weighting the middle one to be larger. Yeah, it's 4. Do you understand what that middle one is? When I say weighting, W-E-I-G-H-T, it's as if if you had 3 exams in surveying, and I said the second exam is more important than the other 2, so I would take your first exam, I would add to it 2 times the second exam, I'd add the third exam, and then I divide by 4. So they're saying that the middle area is more important. Okay, so let's look up here again. So let's look. Cut or fill? Cut or fill? Okay. What do these what do this stuff represent? What you surveyed, right? These are the coordinates, the y and the x coordinates of the points that you surveyed. Why did they put a C in front of it? Because it's all cut. Okay? So the one for fill, here, this represents the coordinates of the point surveyed. This represents the coordinates of the point survey. And they put a C in front of it because this is a cut area. And they put an F in front of it because it's a fill area. This is all a cut area. So looking at this one, how many survey points would you need? How many survey points would you have to survey? How many points would you have to survey out in the field? 1, 2, 3, 4, 5, 6. And you would have a y value, you would have a fraction for each of these points, and they would have a y value of an x, and what would be in front of the y value? F, because of their fill. Okay, let's look back. So we started here. I think everybody's comfortable with that. We looked at this already. We looked at these. This is the, what is this called? Average end area. Here's area 1, here's area 2, here's the length between. They got the average of the 2 times the length. And then you have to, when you're calculating the volume, what conversion do you need? Feet cubed to yard cubed. Okay. Yeah, we looked at this. Yes.
Okay, so, like back to the table.
Sure. The table. This one.
Yeah, so on 1121, 1140, and 1164,
Okay.
like, there's no coordinates or anything on the picture to let us know how much to get.
Right, so they didn't, let's go back to the picture. Actually, they're not telling you, they didn't show you enough information to give you the areas,
Okay, so how
right?
do we know?
So here, we don't know what the areas are, right? But let's think about that. This to me looks like a trapezoid. Does it to you? It may be a little bit off, but in this particular area, they probably only surveyed this point and this point. Right, so then they knew that this was going to be whatever it was, 15 feet on either side, and they calculated this area. What this picture is for you to be able to see it in 3D when whether we're doing cut or fill, and to notice that we're doing fill at the front, cut in the back, and then here it transitions from fill to cut. We did not calculate what these end areas are, but because I took this and this from the same book, I know that these are the areas for those cross sections.
So we have to be given the coordinates.
You have to be given the coordinates. You have to be given it. So it wasn't until we got here that the coordinates were given and we could actually do the double area method. Or this one where nothing, oh, but here something's given, we could do it. Here something's given, we could do it. Here we did both, right? And now we're going to do some more problems. Good? Okay, so what I want you to be comfortable with now is the language and the vocabulary that we're using, because we have to be able to draw it. So we're going to this. And let's read the top first, but I think you already know this. Okay, what does it say? All y distances numerator. We know the y distances are the numerator. They're referenced to the base of the road. And the base of the road, does everybody see where we are? The base of the road could also be called the road bed. It could also be called the subgrade. So all these three terms are used to represent the base of the road. So we know the y, the numerator, the y distances are referenced to the road bed for both cut and fill, right? And if we're doing the math, if it's, sometimes the y distances are given as elevations. You'll see that in a little bit. All coordinates given represent points on the existing ground surface. Is that right? When you see this, what do you know about these 3 points? They were all surveyed. So they had to be surveyed on the existing ground surface. The coordinates are written on construction stakes placed in the ground to tell the graders to cut or fill in that particular location. Since the stakes can only be placed in the existing ground, the coordinates given always represents points on the existing ground surface. It says draw the cross-section and compute the area of the cross-section by the double area method. So let's start with the first one. They're saying there's a base of 20 feet. All the ones we've done so far had a base of what? 30 feet, 15 on either side. So first thing you do, and we should do this all, draw it to scale. And you're going to finish these problems and you are going to draw them to scale. But right now, just as a sketch, get it out of a blank piece of paper, draw a road bed 20 feet wide. And if you have engineering paper, you can do it to scale. Say every box is 1 foot. Draw a line that's 20 boxes wide.